There's a mystery carved into the Giza Plateau that makes engineers uncomfortable. The Great Pyramid's sides align with the cardinal directions to within 1/15th of a degree. That's more accurate than most modern buildings. The ancient Egyptians supposedly achieved this precision around 2500 BCE using copper tools, rope, and starlight. Now travel 7,500 miles west across the Atlantic to the jungles of Mexico's Yucatan Peninsula. The Temple of Kukulkan at Chichen Itza, built by the Maya over 3,000 years later, demonstrates the exact same obsession with astronomical precision. During the spring and fall equinoxes, the sun creates a shadow along the pyramid steps that looks like a serpent descending from the heavens. Two civilizations, separated by an ocean neither supposedly crossed, both building monuments that track celestial movements with surgical accuracy. This isn't coincidence, it's a pattern that repeats across every continent. Astronomy historian Michael Hoskin spent decades cataloguing Neolithic structures across Europe and North Africa. His research revealed something extraordinary. Over 2,000 tombs and monuments erected before 1000 BCE were deliberately oriented to face specific stars, solstices, or equinoxes. These weren't random architectural choices. They required mathematical knowledge, multi-generational astronomical observations, and engineering capabilities that shouldn't have existed in societies we categorize as primitive. The frozen plains of northern Europe, the Mediterranean coast, the deserts of Egypt, the rainforests of Central America. Different climates, different resources, different languages. Yet somehow they all looked up at the same sky and decided it was worth encoding into stone. The conventional explanation falls apart under scrutiny. Independent invention, they say. Humans everywhere naturally develop similar solutions to similar problems. Except these weren't problems. Nobody needed to align a massive stone structure with the winter solstice to grow crops or hunt animals. This was something else. Something that demanded resources, labour, and knowledge that took generations to accumulate. Consider what it actually takes to align a building with true north. You can't just point at the North Star and start stacking blocks. Polaris hasn't always been the pole star. Earth's axis wobbles over a 26,000-year cycle called precession. In 2500 BCE, when Egypt's pyramids were built, the pole star was Thuban in the constellation Draco. Ancient Egyptian architects had to observe Thuban's position night after night, calculate its lowest point on the horizon, and use that to determine true north. Then they had to maintain that accuracy while constructing a monument containing over 2 million stone blocks. The Great Pyramid's base covers 13 acres. Its sides align to cardinal directions with a margin of error so small that modern surveyors using GPS and laser theodolites struggle to match it. The Maya at Chichen Itza faced a different challenge. They weren't just aligning their pyramid to cardinal points. They were engineering a light show that would only work twice per year during equinoxes. The pyramid has 91 steps on each of its 4 sides, plus the platform at the top. That's 365 steps total, matching the days in a solar year. But the serpent shadow effect required calculating the sun's angle, the pyramid's orientation, the precise dimensions of each terrace, and the depth of each step. One miscalculation and the illusion fails. The shadow appears in the wrong place or at the wrong time. Yet the Maya, working without metal tools or wheeled vehicles, got it perfect. What makes this truly strange is the timeline. Egyptian pyramid building ended around 1500 BCE. The last major pyramid was constructed, and then the knowledge simply stopped. 1,000 years later, the Egyptians themselves were tourists at Giza, unable to explain how their ancestors moved 70-ton granite blocks or achieved such precision. Another 1,000 years passed before the Maya began building their pyramids in Central America. They developed their astronomical alignment techniques independently, with no contact with Egypt, using completely different architectural styles. Egyptian pyramids are smooth-sided tombs with internal chambers. Mesoamerican pyramids have flat tops, external staircases, and temples. Yet both cultures decided that astronomical alignment was worth the extraordinary effort. Now shift your attention to Europe. While the Maya were building Chichen Itza and centuries after Egypt's Pyramid Age had ended, medieval Europeans were constructing cathedrals. These weren't just houses of worship, they were astronomical instruments built from stone. The Cathedral of Chartres in France has a labyrinth on its floor that serves as a lunar calendar. Light through its stained glass windows marks specific dates and religious festivals. The builders encoded the golden ratio, sacred geometry, and celestial mechanics into every arch and column. This was the 1200 CE. Europe was supposedly in the Dark Ages, yet cathedral architects were demonstrating mathematical and astronomical knowledge that rivaled ancient Egypt. The pattern extends beyond alignments. It's about what these civilizations prioritized. They chose to invest enormous resources into tracking the sky. Resources that could have gone toward better agriculture, stronger defenses, or more comfortable living. Instead, they moved stones weighing hundreds of tons, carved precise angles, and oriented entire complexes to celestial events. This wasn't practical, it was philosophical. These cultures, scattered across time and space, believed the sky mattered enough to encode it into their most permanent structures. Some researchers argue this reflects universal human psychology. We all live under the same sky. We all notice the sun rises and sets. We all see the moon change phases. Therefore, it's natural that different cultures would develop similar responses. But this explanation treats these monuments as if they're simple. They're not. The precision required to align the Great Pyramid isn't intuitive. It demands systematic observation over decades, mathematical frameworks to process that data, and engineering solutions to implement it at scale. That's not a natural response to seeing the sun rise. That's institutional knowledge passed down through generations. The uncomfortable question isn't why these civilizations cared about astronomy. It's how they all reached the same conclusions about which astronomical events mattered most. Solstices, equinoxes, pole stars, specific constellations. These aren't random choices. They suggest a shared framework for understanding the cosmos. Or maybe it suggests something else entirely. What if these civilizations didn't arrive at the same conclusions independently? What if they inherited them? Consider the problem of precession. Earth wobbles on its axis like a spinning top winding down. This wobble takes 26,000 years to complete one cycle. During that time, the position of stars relative to Earth shifts. The pole star changes. Constellations appear in different positions. Ancient astronomers tracking this needed centuries of continuous observation. They needed institutional stability to pass knowledge across generations. They needed mathematical frameworks sophisticated enough to calculate movements spanning thousands of years. The Egyptians knew about precession. The Greeks knew about it. Ancient Hindu texts describe it. So did the Maya. But here's what doesn't make sense. Precession is nearly imperceptible within a human lifetime. You can't just look up one night and notice it. You need detailed records spanning centuries, comparing observations from your great-great-grandparents to your own. How did scattered civilizations all independently decide this nearly invisible phenomenon was worth tracking? The standard answer is convergent evolution. Humans everywhere develop similar solutions to similar problems. We all need calendars. We all notice seasonal changes. Therefore, we all eventually figure out astronomy. It's logical, straightforward, and deeply unsatisfying. Because it doesn't explain the specifics. Take the number 360. Babylonians divided the circle into 360 degrees. Egyptians used a 360-day calendar with 5 extra days added. Hindu astronomy uses the same division. The Maya independently developed a calendar system that incorporated 360 as a base number. Why 360? It's close to the days in a year, but not exact. It's divisible by many numbers, making calculations easier, but that's a mathematical convenience that requires sophisticated number theory to appreciate. These aren't obvious conclusions. They're the result of advanced mathematical thinking applied to astronomical observation over extended periods. And they keep appearing in cultures with no documented contact. Move beyond astronomy to engineering. The megaliths, Stonehenge in England, the stone circles at Karnak in France, the dolmens scattered across Korea, the Moai of Easter Island, the walls of Sacsayhuaman in Peru, massive stones precisely cut, transported over distances that seem impossible given the technology available. The conventional explanation is simple. Lots of people, lots of time, lots of effort. Human determination conquers physical obstacles. But that explanation struggles with the details. The Baalbek stones in Lebanon weigh over 800 tons each. They're fitted together so precisely that you can't slide a knife blade between them. Modern cranes struggle to lift loads that heavy. Ancient builders supposedly used wooden rollers, copper tools, and unlimited manpower. Experiments attempting to recreate these methods fail, the stones crack, the rollers break, the logistics become impossible. Pumapunku in Bolivia presents even stranger problems. The stones there show drilling holes with perfect circular symmetry. The surfaces are flat to within micrometers. The interlocking joints fit together like precision-machined components. This is sandstone and andesite, some of the hardest stones on Earth. Copper tools don't cut them. Bronze tools don't cut them. Even modern diamond-tipped tools struggle with andesite. Yet ancient builders carved these stones into complex three-dimensional shapes with tolerances that match modern machining standards. The response from mainstream archaeology is that we're underestimating ancient capabilities. They had time, patience, and techniques we've lost. Perhaps they used abrasives, sand and water to slowly grind away stone. Perhaps they understood leverage and counterweights in ways we haven't reconstructed. Perhaps the precision is exaggerated and we're seeing what we want to see in weathered stones. But engineers who've examined these sites aren't talking about weathered stones. They're talking about right angles accurate to fractions of a degree. They're talking about surfaces that are measurably flat across spans of several feet. They're talking about drilling holes that show no deviation in diameter from top to bottom. That's not patience and sand. That's technology. And then there's the timeline problem. Egypt's pyramid age begins suddenly. The first pyramid, the Step Pyramid of Djoser, appears around 2650 BCE. It's crude compared to what comes later. But just a few generations later, the Great Pyramid of Giza demonstrates engineering and mathematical sophistication that wouldn't be matched for thousands of years. There's no gradual learning curve, no evolution from simple to complex. The knowledge appears fully formed, then slowly degrades over centuries until it's lost entirely. The Maya show the same pattern. Their astronomical observations and mathematical systems appear suddenly in the archaeological record. No primitive early versions, no trial and error, just sophisticated calendars and celestial calculations that demonstrate understanding of cosmic cycles spanning thousands of years. This doesn't fit how civilizations normally develop. Skills build over time. Writing systems start simple and become complex. Agriculture begins with basic crops and evolves towards sophisticated irrigation. Architecture progresses from small structures to monumental buildings. But with certain ancient civilizations, some knowledge seems to start at the top and work its way down. What explains this? One possibility is that we're missing earlier chapters. Archaeological evidence is fragmentary. Organic materials decay. Coastal settlements from the last ice age are now underwater. Perhaps these civilizations did have long developmental periods, but we haven't found the evidence yet. That's plausible. It's also convenient. Another possibility is that knowledge was transmitted. Not through direct contact between Egypt and the Maya, that's too far and too late, but perhaps through an older source. A predecessor culture that developed this knowledge and passed it on before disappearing from the record. This predecessor wouldn't need to be global. Regional centers could have developed and collapsed, leaving fragments that later civilizations inherited and interpreted according to their own contexts. This isn't pseudo-archaeology. It's pattern recognition. When you see the same advanced techniques appearing across cultures separated by oceans and millennia, when you see knowledge that seems to arrive fully developed rather than evolving gradually, when you see precision that challenges modern capabilities, you have to ask uncomfortable questions. Not because you want to believe in ancient aliens or lost Atlantean super civilizations, but because the conventional explanations keep hitting walls. The walls are literal. Massive stones that shouldn't have been movable were moved. Precise alignments that required centuries of observation were achieved. Mathematical constants that demand advanced number theory keep appearing, and nobody can quite explain how. So maybe the question isn't how they did it. Maybe the question is, who taught them? Look at the flood myths. Over 200 cultures worldwide preserve stories of a catastrophic deluge that destroyed civilization. The details vary, but the core narrative stays consistent. A great flood, a few survivors. The world rebuilt from fragments. These aren't just religious parables. They're too specific, too geographically widespread, too similar in their fundamental structure. The Sumerian Atrahasis epic from the 18th century BCE describes gods sending a flood to wipe out humanity. One man builds a boat and saves his family. Sound familiar? The biblical Genesis account follows the same pattern. So does the Hindu story of Manu, who's warned by a fish and guided to safety on a mountain peak. The Aztecs tell of Tata and Nena, who carved out a cypress tree after their god warned them of coming destruction. Greek mythology has Deucalion. The list continues across continents and millennia. When two separate cultures share the same myth, their ancestors either experienced the same event or descended from a common source that did. That's not speculation. That's basic anthropology. And when you have 200 cultures telling versions of the same story, you're looking at collective memory of something real. Archaeological evidence suggests a massive flood around the Mediterranean approximately 7,500 years ago. But flood stories exist in China, the Americas, Australia, regions separated by oceans. Some researchers, including archaeologist Bruce Mass, propose these narratives might connect to an oceanic asteroid impact between Africa and Antarctica that triggered massive tsunamis. Others point to rapid sea level rise at the end of the last ice age, when melting glaciers raised ocean levels by hundreds of feet, drowning coastal settlements worldwide. What matters isn't the exact mechanism. What matters is that something happened. Something traumatic enough to be remembered across cultures for thousands of years. And if that catastrophe destroyed advanced coastal civilizations, we'd expect exactly what we see. Survivors scattered across different regions, carrying fragments of sophisticated knowledge they no longer fully understand. Building monuments that preserve astronomical alignments they can calculate, but not explain. Inheriting techniques for moving massive stones they can replicate, but not improve upon. This explains the sudden emergence problem. Egypt doesn't show gradual development from primitive to advanced. It starts sophisticated and slowly loses capabilities over centuries. The Maya appear with complex calendars already functioning. Their astronomical knowledge doesn't evolve through trial and error. It's present from the beginning, accurate and complete. That's not how civilizations normally develop unless they're inheriting knowledge from somewhere else. Consider the pyramid phenomenon. Egypt stops building pyramids around 1500 BCE. Their construction techniques are already degraded, nothing matching the precision of the earliest examples. Then, thousands of miles away and over 1,000 years later, Mesoamerican cultures start building pyramids. Different architectural styles, different purposes, but the same basic form. The same understanding that massive stone structures aligned to celestial events carry symbolic and practical significance. Mainstream archaeology calls this independent invention. Similar environmental pressures and human psychology naturally produce similar solutions. And that's partially true. Humans across cultures do reach similar conclusions about fundamental things. But the similarities go beyond general concepts. They extend to specific techniques, precise astronomical alignments, mathematical constants that require advanced understanding. The Great Pyramid encodes pi in its dimensions. The Maya calculated the solar year to within seconds of modern measurements. The Karnak megaliths in France are positioned on earthquake fracture zones and made from quartz-heavy rocks that generate electricity when compressed. These aren't general similarities. These are specific applications of advanced knowledge, and they all appear after the flood myths say the old world ended. You're seeing inheritance, not invention. Survivors teaching what they remembered to cultures that developed around them. Knowledge filtered through generations until the understanding behind the techniques was lost, but the techniques themselves persisted. This is why ancient structures show no learning curve. The knowledge was already complete. It just degraded over time as the original context disappeared. This isn't about ancient aliens or mythical Atlantean super-civilizations. This is about human beings who developed sophisticated capabilities, suffered catastrophic loss, and passed on what fragments they could to whoever came after. Modern archaeology keeps hitting this wall because it's built on the assumption of linear progress. Primitive to advanced, simple to complex. But history might not work that way. Civilizations rise and fall, knowledge accumulates and disappears. What we call the beginning of recorded history might actually be a reboot after a crash that erased most of the previous save file. The evidence sits there, waiting. Massive stones moved with techniques we can't replicate. Astronomical alignments requiring centuries of observation achieved by cultures that supposedly just invented agriculture. Mathematical constants embedded in structures built by people with no written number systems. Flood myths describing the same catastrophe across 200 cultures separated by oceans and millennia. Every conventional explanation requires us to believe in extraordinary coincidence, that scattered cultures independently developed identical solutions to complex problems, that precision engineering emerged without practice or evolution, that sophisticated astronomical knowledge appeared fully formed in multiple locations with no developmental phase. Or we accept the simpler explanation. Something was there before, something sophisticated enough to understand mathematics, astronomy, and engineering at levels that took us millennia to rediscover. Something that ended catastrophically, leaving survivors who carried fragments of that knowledge forward. The walls they built still stand. The alignments they calculated still function. The knowledge they encoded in stone and myth still whispers across thousands of years. We just have to be willing to hear what it's saying. What? Not that we've discovered everything about human history, but that we've forgotten most of it. The ancient world isn't a puzzle we're solving from scratch. It's a picture we're reconstructing from pieces that survived a disaster we've collectively forgotten. And those pieces keep telling us the same thing. Someone knew this before, someone built this before. And when their world ended, they made sure we'd have the tools to figure it out again. We just had to be willing to ask the uncomfortable questions and follow where the evidence actually leads instead of where we expect it to go. The stones don't lie. The alignments don't shift. The mathematics encoded in ancient structures remain constant, regardless of how uncomfortable they make modern academics. We've built a timeline of human history that requires us to ignore pattern after pattern, to explain away precision as luck, to attribute sophisticated knowledge to primitive trial and error. Eons. But the walls at Baalbek still stand with their 800-ton blocks fitted so tightly that knife blades can't penetrate the joints. The Great Pyramid still aligns to cardinal directions with accuracy that modern GPS struggles to match. The Maya calendar still calculates the solar year to within seconds of our atomic clocks. And flood myths still echo across 200 cultures describing the same catastrophic event that supposedly never happened. Maybe it's time to stop defending a comfortable narrative and start examining what's actually in front of us. Not ancient aliens, not mystical lost continents, just human beings who knew more than we've given them credit for, who built better than we assumed they could, who remembered longer than we thought possible, and who left us messages in stone that we're only now beginning to understand. The question isn't whether something came before. The evidence already answered that. The question is whether we're ready to rewrite the story of where we actually came from.